the biggest architectural bet the industry has ever made.
The NATIX is a world model. It took 2 months for Tesla Robotaxi to match Waymo in Austin, Texas. Even an engineer who has designed this end-to-end model does not know for certain exactly how is this model thinking. Elon can have his perspective, but don't agree with what he said. We could see a world where most cars are self-driving, where most tasks are automated by humanoid robots.
All right. Hello to everybody, especially from our community at NATIX. Today, we have a very, very special guest. Quite excited, actually, for today's conversation. So we have Mohammad Zain from Autoware Foundation. Recently, we actually announced our partnership with Autoware to support them to build their end-to-end model, which I believe it would be one of the largest open source end-to-end models. So Zain, thanks again for joining us today here. Maybe let's just start by introducing yourself and Autoware. I mean, I think a lot of people have read about you guys through our blog and announcement and so on, but I think it's worth one more time covering that from, with your own words.
Great. First of all, thank you so much, Alireza, for having me on today. It's a pleasure to be here, and big shout out to your community as well. Hi, everybody. So a quick background about myself. I have about a decade of experience in the self-driving car space as an early software engineer at Oxa, startup founder as well. And I've been working with the Autoware Foundation for almost 2 years. Recently took on the role of being the president of the Autoware Foundation. So what is the Autoware Foundation? We're a nonprofit organization with over 100 members. These include large players like ARM, AMD, AWS, Red Hat, through to startups, as well as some of the top university research labs in the world. And our mission is to democratize access to physical AI by working together. And Autoware Foundation hosts and manages the Autoware open source self-driving car project. It's been under development for over a decade, and our technology has been applied to a plethora of driving platforms ranging from robo-buses, robo-taxis, driver assistants, warehouse AMRs, off-road vehicles, you name it. So we've really been this open source kind of platform solution for a lot of big players in the industry. And now we're basically taking the next step, evolving from more of a traditional robotics rule-based approach towards an end-to-end AI-based approach. So excited to be here today.
Yeah, thanks for the intro. So I'm gonna pick on a few of the topics that you mentioned. This going from the traditional approach, which was rule-based, to end-to-end. Right. So for years, AV was hard-coded. It was hard-coded modules. Now it's one model that learns the whole task. It's the biggest architectural bet the industry, I think, has ever made, in my opinion. And it kind of came after the LLM, era, I would say. But maybe you can tell our audiences, what was the old model? What is this new end-to-end model that everybody is talking about? What is the buzz there, and why are you guys specifically excited and are working on it?
Sure. So like you said, Alireza, the self-driving car industry has been around for a while, beginning with the Google self-driving car project and then evolving into all of the startups that we know about. So in the past, you would have a self-driving car made up of distinct modules that were coded up by engineers. Modules for perception, which is where you understand what's happening in your environment. Modules for planning. Sometimes you also have mapping and localization. So basically, hand-coded rules that are stitched together and optimized by a very large team of engineers. That type of approach has worked in the past, but as you can imagine, it's difficult to hand engineer complex scenarios. It's hard to hand engineer predictive scenarios of interactions between multiple users, giving way, taking away, these kinds of things. So one of the challenges the industry faced was, how do you handle these types of difficult negotiated driving behaviors? And number two, how do you scale? Because if you've tuned your rules-based system in one geography for one type of driving behavior, how do you adjust it for another geography with different driving behavior? Think Mumbai versus New York. It's different worlds. So this motivated the industry to search for more data-driven approaches where your solution gets better with data. And we saw the explosion of neural nets, from the original ImageNet paper in 2012 through to where we are today. And neural networks have become more and more powerful. The data to train these networks has become exponentially more available. And the compute resources that are at our disposal in the industry to train these networks has also gone on a very steep curve. So, companies like Tesla and others have been taking a data-first approach for a while, but recently there's been this transition where, instead of having different learn modules, you just have one big network that learns to drive. This is what we refer to as monolithic end-to-end. So sensing comes in, there's a lot of AI processing, and driving comes out. And this has really been accelerated not only by things like LLMs, which I'd say is like the current frontier, where you have a vision part, which is looking at the images, a language part that does some reasoning. That's definitely one vector, but another is Gaussian splatting, neural reconstruction, and what we call world models. So neural networks are not only very good at driving cars, they're also very good at simulating the world. And so you can actually build a photorealistic, physics-accurate simulation. And that has also been one of the big factors that has propelled self-driving to adopt this end-to-end approach. So now the more data you have, the better your world model, the better your world model, the better your driving model. And it's this, positive feedback loop. But at the end of the day, it's driven by data. So the more data you have, the better it gets.
I love that, actually. I think that was one of the best explanations that I could give, because we are working a lot with world model teams, with end-to-end model teams like yourself. And a lot of, people are asking us, so what the hell is a world model? What the hell is an end-to-end model? But just to recap, basically the old system was like, hey, it was perception, it was control. What does that mean is, the car, if there was like these if-based rules, right? If you see that the distance between, you and the car in the front is decreasing, then press on brake, which is the action component, right? Which is the control component. Yeah. But this end-to-end model is like, instead of putting all these detailed rules and so on, and then when something is not working, going back to your engineer and redoing all of these things or refining these things, is pretty much like human beings, right? We learn by experiencing, right? We go to the driving school, or we try things and then we experience it. We don't, every time we were supposed to, press brake, we don't like have these if loops, in our head. It just happens subconsciously, I would say. Would you say that is like a right kind of parallel to draw?
Yeah, I think that's a pretty good analogy. Although I would say that human beings are still very sophisticated in the way that we learn, in the way that we arrive at this problem, because a learner driver can learn pretty quick how to drive. But a self-driving car today still requires thousands and thousands of hours of data. So there's still a gap, but obviously it's trying to mimic the same thing that you learn from experience. So you show the self-driving car model, this is how people drive. It learns a pretty good policy on how it should drive, and then you kind of refine it and make it safer and better.
That's why I guess people or companies like Tesla are leading the game, right? Because they have this huge data engine that is constantly giving them more and more data, not just normal data, but what I am pushing a lot these days on social media is edge cases and long tail scenarios, right? And when you have more of this distributed, decentralized data network of normal non-expert drivers, like people that are normally driving, you get a better distribution of the randomness and wildness of the real world, and that translates into a better model. One thing that you mentioned, since you are an expert in the field, I would love to hear it from you. What is a world model? What is an end-to-end model? What is the connection between these two? Why are these buzzwords that we're hearing all around within the physical AI, right? Not just in autonomous driving, but also in embodied AI, robotics, and so on. What are these things? What is the end goal with these things? Because people might not know the distinction between these two.
Sure. So I can break it down quite simply for you. Let's start with an end-to-end model. So an end-to-end model is basically a neural network where you pass in some information from sensors, and the model has some output in the form of actions. So you can think of it as a brain. that just says, this is what's happening from the cameras, and I have to, turn the steering wheel this amount or apply the brakes this amount. You could think of your end-to-end model as a virtual AI driver or a digital AI driver. Now, in the past, the standard approach for training or making this digital AI driver was that you just show it examples of this is how people drive, because you have the input and you have the ground truth measurement. That approach works fairly well, but it's not always good enough because, like you said, there's always a limit in the distribution of your data. What ends up happening is that when you actually put that virtual AI driver in a physical car, there are small errors, lags, delays, unforeseen circumstances, and your AI driver ends up making a mistake and never recovers. And those errors build up over time. So what you have to do is you have to somehow let your AI driver make a mistake and then recover. One way to do this is you go on a physical car, you drive down the road, and as the vehicle makes a mistake, you nudge it with a human being. That's not really so safe, and that's not really so scalable. So the alternative approach is, can you build a virtual world, a virtual simulation in which you put your AI driver and it can make the mistakes and learn from its errors. So that is what I more or less call the world model. It is a AI simulation of the world, like the Matrix is a world model. The more realistic it is, the better it captures the physics, the better it captures the appearance of the world, the behaviors of the world, the better your AI driver becomes. So now we're seeing companies that go almost straight from, here's an architecture for a driver, a virtual driver. We will never drive on physical roads. We'll just go straight into this photorealistic simulation, into this world model. It's like a dojo. It's like a training ground. You just learn in that, and then it's pretty good on the road day one. So that's the distinction. The end-to-end model is your digital AI driver. Your world model is your photorealistic simulation of the world, which you use to train and improve this digital AI driver.
Yeah, that's very interesting. Would you say that this old approach that, for example, Waymo had, we're talking like years ago, that's why they could not scale that fast and just suddenly go to all the cities? I assume that the reason was, like you explained, every time they have a new model, they had to, do some test driving in the new city, right? And then put some expert driver. And then when the model was not performing well, the expert driver kind of teach the model that, hey, do not steer right, you have to, or steer right, not so aggressively. And then you kind of fine tune that. And this whole process of going back and forth, it was taking very long time, right? Would you say that was the reason that we were slow in expanding AV? And would you say this could be the reason that we can go to market much faster, or have adoption, much faster at scale?
It's one among multiple reasons. For example, there's another distinction that needs to be made, which is, does an AV rely on a high definition map or not? So what is a high definition map? It's like a Google Street View on steroids. It's a 3D centimeter accurate measurement of everything in the environment. So companies like Waymo and others have relied on these high definition 3D maps, which are very hard to construct. It makes your driving task way easier because you can just refer to your map. But when you go to the end-to-end model, you don't really need that map. You just use a standard navigation map. And that allows you to expand much more easily because navigation maps are available all over the world. You don't need to go with laser scanners and survey every road and then annotate every lane line and every traffic light. So essentially, it's shifting from offline data to online learning and online reactive driving. You see, you drive, the world changes, you see again, you think, you drive. And you have a standard Google Maps type interface to figure out where to go. So I think it took 2 months for Tesla Robotaxi to match the geographical coverage of Waymo in Austin, Texas. So that is just showing you how quickly, if you have a good end-to-end approach, you can scale up a system.
Yeah, we wrote an article some time ago that's exactly how we saw it as well. That we're going from map-based driving to mapless driving, right? And the intelligence is becoming more and more real time and online, and it's based on the ego perception or the perception of the car, right? It's very similar again to a human being. I know I'm simplifying this, but that's kind of how I draw the parallel. And I think that whatever that I'm seeing within the industry is that we're trying to get closer and closer to how a human brain, as well as our sensory setup, functions essentially. But yeah, so a kind of a maybe a tough question. Do you actually think end-to-end models are going to be safer, or are we kind of sacrificing interoperability for scale, so to say? Or you actually think this is going to be, because one thing is you have adoption faster and more broad, and some people have been not very, I don't know, from what I'm seeing is, some countries are more lenient towards safety, some countries are much crazier towards safety, Europe being the toughest one here, right? That's why we don't see much happening here in terms of self-driving cars. But where do you see this end-to-end model? I guess that's about, or you really think this is going to be both safer and more scalable, or maybe one of them?
So that's a very interesting question, right? Because essentially you have taken all of the driving and put it in a black box. So even an engineer who has designed this end-to-end model does not know for certain exactly how is this model thinking, right? There are lots of papers and approaches that try and introspect these models, but no one can say with absolute certainty, this is how the model took the sensor input and arrived at the output. So we have gained scalability, but we've sacrificed the ability to introspect the model, and therefore the question of safety arises, just as you mentioned. So actually our approach within Autoware is to have a hybrid system. So you have an end-to-end model that maybe relies on the cameras of the vehicle, and it does the majority of the driving. But you have a parallel system which runs what we call safety perception. That could leverage physics-based sensors like radar or LiDAR, things that shoot out information in the form of EM waves into the physical world, and they tell you, is something there or is it not there? And that acts as an alternative signal to stop or go. So there will always be edge cases with any AI-based system, because an AI-based system learns from data. And with driving, you will always end up with edge cases. If you imagine 1 million cars driving 1,000 miles a year, which is not that much, you end up with 1 billion miles, right? If you think of 10,000 miles a year, that's 10 billion miles. So you will encounter a 1 in 10 billion miles scenario with a fairly small fleet driving fairly few miles. So it is critical that we address these edge cases. And this safety layer must be introspectable. I should be able to see that this is how the input came, this is what was processed, this was the decision. So I think that just saying end-to-end AI, that's all you ever run, and we'll just train it on 1 billion miles or 1 trillion miles and it'll get safer, isn't really the most scalable approach or the most robust approach. But use your physics-based logic where it works, and use your end-to-end where it helps you scale, and have a system that is the best of both worlds. That's what I think the industry will eventually settle on.
What do you think of this statement that Elon made, that the reason he has been super against these, let's say, physical sensors, right, or physical measurement sensors like LiDAR and radar, was that when you want to try to do some sort of a fusion, it makes the system slower. What do you think of that argument? Is that relating to what you said, or that's for something else? Maybe your architecture that you just described is something different.
Well, I mean, Elon can have his perspective. To be honest, I don't agree with what he said because it doesn't make sense. It's like, oh, we have a sensor that works in fog, nighttime conditions, and rain, but we're going to ditch it anyway because we don't know how to use it. It's always better to err on the side of caution. So if one of your systems says, this is risky, slow down, you should slow down. even today, you mentioned Tesla as a leading player in the space. Yes, they are pretty awesome, and Tesla Autopilot is a highly deployed, very advanced, amazing technology. But they still have a lot of incidents that are under investigation by NTSB, where a human being would not have crashed, right? Because you can see it. Similarly, there was ADAS testing done in China with leading OEMs, and many of them had end-to-end models and many sensors, and they were crashing in very simple scenarios. So although we're trying to have scale, we still have core safety gaps that need to be addressed. So we can't just say scale, 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 build, 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 drive, 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 and ignore the safety. Whereas I think Elon has that vision: just build, 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 and eventually we'll reach a threshold. I think we need a more principled approach that does put safety first.
I fully agree. I think it also, in my opinion, stems from how the regulators look at this from different environments, right? I think Chinese and US regulators has been known to be more relaxed with these things. Europe-based regulators, where most of the strong OEMs are, they're much more strict with these kind of things. But it's quite interesting actually to see how this bet kind of evolves. But when you said Tesla has accidents, some people are basically counter arguing that those accidents are still much less than human caused accidents, right? Because people are texting and things like that. So at the macro level of things, this is still saving human lives, right? Is this a statement correct, or is it just trying to deflect from the reality in a way?
I think it's the latter, because Tesla has a lot of people that pull data from the vehicle, and they have dashboards. I was looking at one of these dashboards not too long ago, and from my recollection, I might be wrong, Tesla vehicles on autopilot / FSD have a disengagement after every, I think, 2-3 hours of driving, something like that. So when I'm talking about 1 in a 10 billion mile scenario, that's different level. And if you look at the types of collisions that have happened, no human being that's paying attention would have had that collision. Obviously, there's collisions that you cannot avoid, but this is clearly a gap in the AI. It's very obvious that if there's a parked, overturned truck on the road and you drive into it at 70 miles per hour, you haven't seen that truck. There's a parked police car on the side of the road with its lights flashing, and you drive into it at full speed, or you brake in the last half a second. That's not really, I would say, what a human being's level of driving is. So a collision is not the best measure of safety. If a collision has happened, you've already made the mistake. So we need much better metrics. Like, for example, LLMs, their metrics are available. So if OpenAI launches a new LLM, everybody can go to the dashboard and see how well it does. Unfortunately, we do not have similar metrics in the self-driving car space. Companies are not nearly as open about their performance in these scenarios. And most of the standard tests that you get on a test track are super basic. They're very, very simple, and you can pass those tests and still have a system that is not ultimately safe. So yes, Tesla is a very sophisticated technology, but any AI system will always, always, always have edge cases. And you can never say that an AI system is 100% safe. You always have to have safety guards, alternative systems, or even multiple AI systems, so that the chance of all of them failing at the same time is lower. So personally, I would never just say, here's one big model, it's safe. Don't worry about it.
Yeah, I fully agreed. By the way, I had this discussion because we're in the business of edge cases, right? So that's kind of like our bread and butter. And back in the time when we just started, I asked somebody, so like, can you give me a comprehensive list of edge cases, And then the guy was like, yes, I can give you what I think of, but that's the definition of an edge case, is that I don't know what it is. It's the unknown, right? So, I mean, what I'm trying to say is, it's such a it's such a rare thing, and edge cases also evolve, right? The edge cases that we have right now versus in 5 years where we have more autonomous vehicles on the road, right? You see the edge cases right now, some clips of Waymo versus Waymo, then they completely lose their brain, and they start doing crazy stuff that is quite funny. I don't know if you've seen those videos, but yeah, these are edge cases, and edge cases keep evolving. Yeah.
I mean, edge cases are there. Sorry, go ahead.
No, you go ahead. Go on.
I was just going to say that, there's two types of edge cases. One is, like you said, the unknown, right? A man in a clown suit is riding a horse in the middle of the highway, right? Nobody can imagine that happens. But there's still known edge cases where leading systems still fall short. And I think there's a lot more that has to be done to even address those. So, we have testing procedures for very basic levels of automation, like basic braking features, basic warning features, and the industry has not caught up to this new paradigm. So I think regulators really have a job right now to build a lot more robust safety systems. And I mean, in California, for example, they publish these disengagement reports, but Tesla Autopilot doesn't necessarily publish disengagement reports because it's not a full self-driving system legally. It's still a driver assistance system. So for someone to make the claim that, yes, we address all known edge cases, show me your numbers, and then I'll believe you.
Fully agreed. By the way, there was this recent study, I think you saw it as well. It was from a university in Germany, and they started to test these models basically in graphic-based simulators, and then putting like just elephant, and all these kind of like
field drive.
I think so. Yeah.
I came across it. It was
I think it's from Tübingen,
I believe. Yes,
exactly.
Yes.
And it was so funny. And then the numbers were crazy. I mean, most of these models are failing at such a simple things. I mean, yes, it's an elephant, but is it still something crazy on the road? Your model shouldn't lose it at the end of the day. And I mean, I fully agree with what you said. And it's not just a statement, in my opinion. Like, people are more and more showing this, that these models are far away from most of them. And the problem, as you said, I mean, we have the same thing right now with world models is, everybody's building a world model. A lot of them are also closed source. There is no way to compare these things, right? There are some projects that are doing comparisons of world models, open source ones, right? But for us to get a, quality of Gaia, I mean, they have been leading this thing, and I'm super bullish, and amazing team, but nobody really knows because everybody has just seen a blog article, right? Nobody really has tested it versus another open source model or another model, or the one that recently came out from Waymo, or the Tesla ones, right? So we have no idea how these things are performing according to a standardized benchmark, and
exactly.
Maybe that kind of brings me to this open source question, the importance of open source, right? Because these are closed source and it's hard to compare them, and maybe in a utopian world, this could have been done and it would speed up everything. But basically, how do you think about this? Tesla has billions of miles. Waymo has the most mature stack in the world, or arguably one of the most mature stacks in the world. You have Wave as well. Realistically, can open source ever catch up, or is the data gap the problem? Or because I loved when I talked to you regarding open source, and when we started committing to Autoware, I was like, okay, open source sounds amazing, but how can we actually make money out of this, right? How can the ecosystem make money out of this, right? How can we support everybody and not just give IP away? And you gave me a very good argument. I mean, I would love to dig deeper right now together, but I think a true open source person can really look at it from a different perspective, because a lot of people might think, okay, it would never catch up, and it's just some research work essentially.
So, the whole philosophy of open source is to democratize access, right? Because if you think about AI, for any frontier AI application, it's super hard to build good AI systems. Like you said, Waymo or Tesla or Wave, these companies have tremendous resources at their disposal, and they have very good engineers and scientists working in closed source to build these applications. So for any other company that is not maybe these 2, 3, 4, 5, whatever companies, it is impossible to catch up. So our perspective is that this technology is an asset for all people. It's not just an asset for a handful of technology companies that will then just own the entire space, but this should be a shared asset. And that if we can build the open source technology to a sufficient level, maybe not matching one to one, but maybe 90% or 95%, and give you the recipe, then many other companies can fill that last 5% gap. And although we are an open source institution, we have some of the biggest companies that are working with us as well, be it chip makers, technology developers, or the top research labs, because they all believe that rather than one company building this on their own, building the whole thing vertically, can you bring together a group of people, a group of industry players to collaborate in the open and build something that has shared value? And the other thing is, yes, we're open source, but we want this open source technology to have commercial benefit for the people that have helped to build it, so that there's a return on the investment. So we want to make it open. We have a very permissive license. It's Apache 2.0. So you can use it for research purposes and commercial purposes. And you can build products on top of our technology. You can run services. So really, it's all there. The idea is that you want to make the technology available to everyone.
That's I fully agree with that, and I think you know, I think democratizing technology and giving access to people is a positive sum game, and I'm all pro it. Maybe a question that I have on how you see this: what's the open source angle that closed players can't replicate eventually, right? What could be leading here at the end of the day?
So being open, because if you're closed, right, only you or your handful of ex-engineers have a chance at making your code better or improving your code from within your silo. But if you're open, if there's a bug, then anybody has the chance to find that bug and fix that bug and submit a pull request. You can look into the lines of code one by one. You can look into the model architectures, and you can improve it at a much faster rate because it's open. I think if you look at the operating system space, whether it's Linux for servers or Android for smartphones, there was always closed source alternatives. But in both spaces, an open source solution became the dominant one. And I think that in other physical AI applications, we'll see a similar trend where you'll have this open source technology, that's the substrate, and then you customize it. You have different flavors of that technology that are optimized for a specific use case or by a specific company. But I think being open is actually a very big advantage because you build in public, you build trust, you share your metrics. If you have failures, they're public. If you have a success, it's public. You believe in it. If I see a demo by XYZ self-driving car company, how do I really trust that demo? How do I know that they didn't do that specific road 50 times before they made that video? How do I know that, but just because it says self-driving in the top right corner, is it actually self-driving? But when it's open, you can download it, get a car, run it yourself, and know for sure. So there's no hiding. I think that is very powerful. That builds trust, and it also helps us get better much faster.
Fully agreed. A big part of open source is like there are parallels between open source and crowdsourcing something, in my opinion. And our company, for example, is built on the foundation of crowdsourcing the data in that sense, right? And I think a lot of centralized data players, can't compete with us because we're using the power of crowdsourcing. Even from financial reward point of view, we're giving them a piece of our economy. I mean, that's a little bit of a deeper discussion, but including people into this and then having, this crowdsourcing effect. I mean, in open source, there's a crowd pool of people that are contributing to the code, right? In this case, they're contributing to the data. And, in our business, it creates a flywheel because, as you said, like, right, because it's open, the more the better the system essentially gets, that attracts even more people to come and use it. And when people coming and using it, they improve one or two things, right? And then the more people that you have, there's more weight added on. And I think at the end of the day, we're going to get to in this case, to a safer system much faster. So that's yeah. I also think the open source is the way to go. More and more people are realizing it. And I'm always fan of looking at history, as you said, when you look at Linux and these open source operating systems, and we have many other open source protocols, right? These have performed better than the centralized one in most of the cases, right? And they became kind of like a go-to platform for a lot of businesses to build on. Going away from end-to-end models to world models, let's talk world models a little bit. That's kind of what excites me, at least these days. It's something as an enabler for an end-to-end model. And we're working with a lot of labs actually already. So I'm sure but for our audiences, Wave has an open source model. Wave is one of the top autonomous driving companies these days. They raised a lot of money. They're showing a lot of interesting results. NVIDIA has Cosmos. Tesla has its own neural simulator, which they reviewed recently. What do you think is the future of the world model, and where are we, in that timeline to get into something that is solid that people can use? Because a lot of the stuff that I'm seeing today is still, in my humble opinion, and I would love to know yours because you're even deeper into this than me. They're not really production ready yet. They're nice POCs and some videos and so on, but I haven't seen like a working product using the world model yet. Where do you think we are in that spectrum? And what is kind of the time frame that you expect for us to kind of build something meaningful with world model? And how would that world model look like in your eyes?
It's a very big question. I think a good analogy for everybody listening is to think about AI image generation, AI video generation, and then AI world generation is just, let's say, the ultimate version of that. So if you think about AI video generation, a good test was Will Smith eating spaghetti, and there's this video of spaghetti's flying all over the place, and in a fairly short time we've come to very sophisticated video generation models. You just put in a text, and then out comes this HD quality amazing video. And that happened all of a sudden. And now we're seeing that same technology applied to worlds that are synthesized and navigable. So it's not just a video, but it's a video that reacts to how you move in that video and the actions that you've taken in that video. And the rate of change is quite remarkable for reasons I've mentioned, like the data access, or the growth of the data, the compute power, and the architectures themselves. We've now been able to train very, very large neural networks with billions and billions of parameters, in some cases trillion parameters, whereas that would have been unthinkable of in the past, even 5 years ago. To say to someone, oh, I've trained a 1 trillion parameter neural network that does this task is just, not something that we thought was possible in the field. So I think we're getting closer and closer. My personal view is that there's still one breakthrough left to be discovered. And that is not necessarily on the data side or the compute side, but on the AI side. I think that, for your audience, most AI models used to be what's called CNNs, convolutional neural networks. Then we've entered this domain of transformer. So the T in GPT stands for transformer. And that's a different AI architecture. I think we need yet one more AI architecture to really achieve the level of realism where this technology, achieves the level that you need to be production grade in terms of physics, in terms of the visual look of that world, in terms of the behaviors of that world. It's a very hard problem to model the world because the world is so complicated. Yeah. But from what I've seen in the space, the rate of change is quite phenomenal. So I think maybe it could be 2 years or 5 years or whatever horizon. we'll always get better in this field. But if there is a breakthrough, which I think there will be, then you'll see a step change, like the Chat GPT moment. We just saw LLMs emerge from nowhere and become this mainstream phenomenon. I think the same thing could happen in the world model space, and then all of the downstream applications, be it robotics, be it self-driving cars. So we could, in the near future, see a world where most cars are self-driving, where most tasks are automated by humanoid robots, where a world is very, very different from the one we know today. And I tell friends and family about this, and sometimes they're a bit, are you sure, Zain? Is this really going to happen? I'm like, the speed is there. So yeah, I wouldn't bet against it, is what I'm saying.
I wouldn't too. I'm actually all in on it, to be fair. But so would you say that, I mean, so, okay, to recap, you're saying that we need the T in the GPT moment for the world model, for this thing to come into a level that it can be production ready. And with that said, is it safe to say that there is this architecture that I've heard of that comes from Jan LeCun and his team at Meta? It's called JEPA, if I'm not wrong. Is that like kind of the another, let's say, architecture, or that's something different?
I mean,
I'm not
that's
saying
an
it's the
attempt.
architecture. I'm saying it's another architecture. Is it?
Yeah, I mean, it's getting a lot of popularity. It's interesting. Here's my fundamental thesis on AI, right? Any AI model in existence today, no matter what the boilerplate says, is essentially trying to memorize from data, even today. It's just that now it's memorized almost all internet data, which gives the illusion of something that is reasoning, thinking, and logical. However, human beings learn much faster. And so there's two concepts that are still missing in AI models. Number one is flexibility. If you design AI architecture today, be it JEPA or GPT or whatever, someone designs the model and it's frozen. The neurons and the connections are frozen, they don't change. Whereas in our minds, we form new neural connections. Old ones die, new ones are formed, we branch out. So we need an architecture that evolves over time, that doesn't exist in the space just as yet. And number two, human beings are very good at storing memories and learning from our memories. So if I touch something, I burn my hand as a kid, and I see there's a bit of steam. Next time I see something with a bit of steam, I probably won't touch it. But no neural network today will learn from one example. You'll have to touch it 1,000 times or 10,000 times to learn bad, 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 bad. Okay, don't do it. So what I mean is that it's not just a tweak. We need to rethink the paradigm of how we design AI models. And in my personal view, flexible architectures that can evolve and change themselves, and memory. So having a memory of what happened in the past, what happened a year ago, what happened 5 years ago. And that's where you start to get into what I would say is ASI or AGI. So when we get to that level, then it's a whole different ballgame.
Fully agreed. Fully agreed. I think for a lot of people who haven't really, touched or seen, world models, a good parallel that I can make is for a lot of us these days whom are using Claude, the real game-changing thing for me was the memory. Actually, that's what kind of changed everything. This whole agentization that we're going through. One of the most important things is the memory, actually, right? And that's just on the text generation, right? And LLMs can just do text generation. LLMs can only generate, predict the next word, generate language, generate, ideas. I wouldn't say like, creative ideas all the time. It's based on the collective knowledge that we have put into internet. But they're very good at generating ideas. They're not yet good at predicting the next phase of the real world, right? Predicting four-dimensional reality. So I fully agree actually with how you see it as well. I think these two aspects that you mentioned, forming new neural connections, destroying the old ones, as well as the memory, is going to be a game changer. Some people actually argue world models are overhyped, that you don't actually need them. What do you think? I mean, people are raising orders of magnitudes of billion for this thing, which is very exciting. But I mean, their argument, some of their arguments is that, hey, you just need more real data, real world data. What do you think of that? Where do you land there?
Well, like hype can be measured in many ways. We're seeing a lot of interest in AI in general, right? Be it with LLM companies or self-driving car players that are AI first, because of the capacity for AI to do so much of what we have done as labor in the past, be it online work, physical AI, embodied AI, AI software. Right now, we're at the stage where people are being helped by AI. So that the human effort has gone down for the same task, and that has been replaced by AI. Eventually, that'll happen more and more and more and more, and then everything will be done by AI. So from an investment perspective, people are very excited about this future because everything is done by AI. Coming to the idea of world models, you're right. You can train self-driving technology without world models. You can even train an end-to-end AI without world models. But a world model is a convenient way and a very, I'd say, quite a robust way to get results quickly and to be able to visually see how your car is doing and to be able to test your system. Really, a world model is a better simulator. People have tried to test vehicles in simulation. They've done this for decades, and the better the simulator, the better your test results. But the problem was no simulator was really that good, and there'd always be a gap. So you could test your system, but when you come to the real world, there was this sim to real gap. So you could only use it for testing. Now, a world model makes this gap smaller and smaller and smaller and smaller. So you can actually just train in a simulator. So if you have a lot of computers, you can just train a virtual driver and it gets pretty good, and then you can deploy it. So that is, again, the thing that excites people in the AI space, in the self-driving car space, about world models. And the idea of world models is exciting because they learn not only visual understanding, but physics and relationships between actors. And you kind of have a lot of information baked into that single world model. So it's a very powerful AI tool in that sense. You can branch off of a single world model for multiple downstream tasks. There was a paper by the Google team recently on how they used the nano banana video generation model to do things like image segmentation, instant segmentation, bounding boxes, all of this stuff, because it had learned about all of those tasks implicitly.
Yeah, it's a scary word. Or we were looking into some pipeline, which was perception-based pipeline, and we were looking like over 1.5 years, due diligencing partners like who can help us and so on, and then just the amount of open source and available models that came out in the past like 3-4 months that can do this, it just blew our mind away. And then I was like, okay, AI is not anymore. AI is becoming, models are getting so good, and it's getting easier for somebody that wants to build a business. It's not anymore like gated, closed within a company, and then you had to go to that company. And I mean, it's getting scary good. Fully agree with you. You actually touched on the simulator. I would like to expand a little bit on this. So for the audience that don't know, we have this graphic-based simulator, as you explained, right? We have the Carlas of this world. It just looks like that's my explanation. It looks like a GTA game. I think everybody has played GTA, right? You're inside the world, and there's cars, pedestrians, trees. It just looks like a version of the world, just in a game, right? And it also has the physics of the real world, right? So it's a physics engine. And then you have the new ones, which are the neural based simulators, right? What you basically build with a world model. So would you say, and I would also love to show our audiences even examples of each one of them. Let me see if I can share my screen. But would you say that neural sim, so these world model based simulators, would kill Carla style hand built simulators, or do they coexist?
Great question. I think for the moment they definitely coexist because it's not easy to run these world models, especially if you're just a developer at home. If you have a laptop like I do, you can't just run a big world model that requires 24 gigabytes of GPU VRAM, but you can run this game world. The game world has its pros in the fact that it's like very deterministic, it's based on simple physics, but it doesn't look that realistic. Even if it does, to AI, the small changes at the pixel level will still be enough to throw off its ability. So Carla, for example, has now begun to integrate neural simulation into its physics as well. So, for example, they've done an integration with NVIDIA's NUREC. So that allows you to bring neural simulation for better visual fidelity, but you still have the kind of low-level physics. This is exactly what I'm talking about. So you can have AI tools that take the 3D graphics of a game engine and make it more realistic, or altogether swap out those graphics with photorealistic generated visuals by pure AI. So there are pros and cons. I think eventually the nature of simulators will change. Eventually, the simulator that we have now will just be like low level, maybe like a simple black white world. It's the black world where you have a car here, a car there as a box. So some box level simulation, and then everything else happens via AI. So AI is the renderer. A good example of this is like NVIDIA Alpha Dreams. So Alpha Dreams is the world model by NVIDIA team. And so you just input this simple like lattice grid view of the world, like a black world with some lines to represent the road edges and the bounding box of the car. You show it, example frames, and then it just renders the world. I think the rendering part will go a lot, will transition from, ray tracing or other types of renderers through to AI-based neural rendering.
That is super interesting. By the way, another thing that I wanted to show, but I didn't want to, kind of go in the middle of what you were talking about. But for the people who are not familiar, again, this would be something like a simulator that a world model can be connected to. I don't know if you have better examples, but I believe Waymo is also using their world model as a simulator. And then, inside this world model is, first of all, photorealistic. So it looks like as if it was collected from the cameras of the vehicle. You can basically create all these different variations. And what was interesting for me is, if you have a real world clip of an edge case, you can basically generate many different variations of that synthetically using a world model. I think something was there in the, so here I think people can see that basically they're changing the scenario. The environment looks more or less the same, but what happens in that scenario is more or less different. So you can create like million different variations of a single scenario that you have synthetically using the world model.
It's very cool. This is actually based on research by Google DeepMind. They developed the world model called Genie 3. So I can actually show you Genie 3. It's very cool. So maybe I can share my screen and pull this up for you. So Genie 3 is like an AI video generation model, except that you can give it keyboard inputs, which is pretty crazy. And it will change the way that the view is rendered based on your input. So you can do WASD or the up, down, left, right keys. So essentially, Genie does not just create videos, but it synthesizes photorealistic, physics-grounded virtual worlds that are navigable. And then the Waymo team took this research, because it's also part of Google Alphabet, and applied it to their self-driving car sensors and the specific mounting angle and size of their vehicle sensors. So then they can generate that data artificially. So this is, again, a frontier world model. Another interesting one is Alpha Dreams. So here, you have the same kind of edge cases, whether it's a car with a mattress or this hurricane. Most of these world model demos have some strange edge case. But this is a video I quite liked because, it also talks to this idea of what will simulation become. So if you have this top left view, which is like a very simple view of the world, you can generate this top right view. So just to be clear, this top right view is generated by an AI system. It's not a camera recording. And what you're seeing here on the bottom right is the more, I'd say now it's classical AI world model technique. And the top right is the cutting edge world model technique, where you have the ability to generate completely novel views that were not part of your original drive. So it's getting more and more sophisticated on a day-by-day basis, and you have new research papers, new models, but they're not open all the time. Most of them are not open. Most of them are very inaccessible. If this were open, I think that's a very, very valuable resource. So that's what we're trying to do. Autoware, NATIX, building out this technology together.
I actually love that idea. We're supporting multiple World Foundational Model teams, open source teams, actually. It's going to come out. The papers are going to come out soon. Some of the best builders that I have seen, and they're actually building something. They have actually built something very similar to what you just showed me. For me, it's for us at NATIX is very important to support this work as well. And that's why I like also being part of the Autoware Foundation. I really believe in the open source. Of course, we are also a business, so we have approaches. We have discussed it, how to take that and to productize that for ourselves and, try to make, revenue from that. But we can just get there faster, in my opinion, when you work with open source teams. That's my motto. And I think it's quite powerful if everybody or more and more people start, doing the same thing. Cool. Just being conscious of the time. Just few rapid fire questions that I wanted to ask you. So just curious to know your answer on that. I have 5 questions here. I'm going to go one by one. I'm just curious to see what you think, and then we can wrap it up. Okay, so ready?
Sure.
Okay, number 1. Perfect. Tesla versus open source end-to-end in 2030. Does the gap close, stays the same, or widen?
Close.
Cool. Does L4, level 4 autonomous driving, for people who don't know, ship on an open source stack within 5 years?
It's already shipped.
I love that. Okay. Will there be a Linux moment for autonomous driving? And if so, when? I know we're close, but yeah.
I think we're almost there. Very, very soon.
Soon. Most underrated data type for training AV models. What's being slept on?
4D radar.
Okay. We should get to that, by the way. I want to know what it is. But let me ask my 5th question, and then you can elaborate. Most exciting new technologies for AVs in the next 3 to 5 years.
Better frontier AI. So, better AI models. When I mean better architecture. So the next thing after transformers.
Yeah, I fully agree. What is a 4D LiDAR, you said?
Radar, 4D radar.
4D radar. Okay.
So just to LiDAR is light detection and ranging. It's basically a laser scanner with multiple beams. So you send out a pulse of infrared light. You measure the time of flight that it takes for that pulse to hit an object and reflect off of that object. And because the speed of light is a constant, you know how far away that thing is. You build up this beautiful picture of the world and you have 3D data. The challenge with LiDAR is that it does not work so well in bad weather because the light doesn't penetrate through fog, rain, dust, snow. So it's not the ideal sensor to handle all weather self-driving. It's a very good sensor to build maps and survey an environment, which is why, players like Google relied so heavily on LiDAR, because they were building these 3D maps. Now, automotive industry has applied radar for a long time. So radar is a technology that's been around for a long, long time. And even in cars today, you get these radars behind the front fascia. So radar has a similar principle to LiDAR, except it's sending out pulses of radio waves. Now, radio waves can penetrate through fog and dust, and they're not affected by any ambient light conditions. But the resolution on these sensors has been very low. That's one thing. The advantage of radar, besides being able to be all weather, is that you have the ability to measure velocity. So you get range and velocity. LiDAR usually just gives range. You use the Doppler effect, and so okay, there's a thing like a car in front of me, and you know how far away it is, and you know how fast it's moving. So it's super useful for autonomous emergency braking and cruise control. 4D radar is basically a very high resolution radar sensor that begins to bridge this gap. So you get all the benefits of radar in terms of being robust in bad weather, giving you velocity, but now you start to get similar resolution to a laser scanner. So now you can use this 4D radar to build maps, to do perception, to detect objects. And so personally, I'm very excited about 4D radar. I think it will be one of the most important sensors that acts as the safety layer for these self-driving cars. So you might have your end-to-end AI that is doing all of the sophisticated driving, and then the 4D radar pipeline is the thing that acts as the safety guardian or the safety perception.
Very interesting. Very interesting. Okay, so we have a candidate that might take over both cameras and LiDAR in a different way, but yeah, super interesting. How new is this? Like who is using it actually right now? Production.
There's quite a few companies that are developing these sensors. A lot of research labs use them. I can go into the details, but there is an OEM that has secured a design, has made a design win or a design specification for a 4D radar in their production passenger car. So it is coming to market in the next couple of years. And I see 4D radar as just improving year on year in terms of resolution, in terms of range, and eventually it'll just match the laser scanners that we have today, at which point you probably won't need a LiDAR.
Wow. I'm gonna read a little bit more about it. Yeah, that's super interesting. It's everything is changing so fast, right? And I think, but I'm genuinely excited, and as you said, I can't wait for new architectures. I can't wait for the T of GPT to come to the world model and to the autonomous driving or physical AI as well. Yeah. So last words, actually. I don't know if you want to wrap up, if there's anything else that you want to say, and would love to also, for our audience to know how to follow Autoware Foundation, how to contribute, if they're autonomous driving developer, for instance, or any other way that they can support.
Sure. You can visit our website at autoware.org. You can look me up on LinkedIn to search for my name. You know what my face looks like. You can also visit our GitHub. You just search for Autoware. We have, almost 13,000 GitHub stars, so you can't miss it. We also have a Discord channel. You can find that from the GitHub. And really, just get involved. We also have a very good LinkedIn page, so you can get in touch with us over there. And I think that being part of this open source community is a great way for people to learn, to develop their skills, to work with industry experts. Doesn't matter if you have a background in self-driving or not. You can be in the same room as these people, learn from them, and eventually contribute and develop your expertise in this space. So I would encourage everybody to be, if you have an interest in AI, just get involved. Just drop into our working groups, find out what we're doing. We're actually about to launch, a brand new working group, which is a robo-taxi working group, where we will build a full open source end-to-end AI system that will be demonstrated on a real vehicle in 12 months. So we'll use things like world models, end-to-end models, and we'll do it in the open. So we're building in public. I encourage you all to be a part of that.
I love that. I love that. Well, we are definitely down. Count us in. And yeah, thank you so much. I believe this was one of the most interesting conversations that I had as part of our AMAs or podcast or whatever you want to call it. But yeah, thank you so much, Zain, for coming. I think I will definitely would love to have you more often, especially when there is newer stuff, happening with Autoware. And yeah, looking forward. Thank you again so much.
Thank you, Alireza. My pleasure. And thank you to all of the viewers and listeners. Really appreciate it.